In previous videos, we have mentioned and alluded to the concept of building models. One of the easiest modeling techniques to understand and to learn are activity diagrams. We begin our discussion of models by introducing you to activity diagrams. First, let's discuss the importance of models and building models during the development process. After we interview the users and determine what they need from the new system, we need to document those requirements so that we don't forget them. How shall we do this? Probably the most powerful technique we have is through building models. So what is a model? A model is some representation of a portion of the real world that must be in the new system. Models are extremely powerful because they abstract out of the real world only those aspects that are important for the new system. Issues that are not important are dropped, and features that are important are precisely and accurately described. In this textbook, we will learn the Unified Modeling Language, or UML. The term language is used in its broad sense as a means of communication. UML is the industry standard graphical modeling language for object-oriented development. One of the most important skills that you will learn in this course is how to build and utilize UML models. Why do we build models? In this slide, we list 6 reasons why models are such a powerful tool in systems development. First, as we build a model, we come to understand the functions that we are modeling. It forces us to understand at a very detailed level and to learn exactly how that function must work. Second, we can remove points that are not important and focus only on what is important. It reduces the complexity into something that is more easily understood. Third, it helps us to remember all the details. Fourth and fifth, models are a powerful communication tool, both to explain technical details to other team members and to explain aspects of the solution to outside stakeholders. Finally, models are a simple way to document decisions that were made for future reference. We will start our modeling skill by learning about activity diagrams. Activity diagrams are one of the easiest models to learn and to use both for systems developers and for users. First, let's define a workflow. A workflow is a sequence of steps that a user goes through to carry out a business transaction. In many of our examples, a workflow is usually a person interacting with the system. An example might be a clerk posting to a customer's account. The steps of that process are a workflow. An activity diagram, then, is an easy way to describe that sequence of steps. It is a useful technique to document a workflow. It is also a UML diagram, although it is not specifically an object-oriented model. Let's look at the symbols that are used in activity diagrams. Remember, we are documenting a sequence of steps. A swim lane is a rectangular box that represents those activities done by one person or one entity. Think of a swim lane in an Olympic swimming pool. Each person or entity has their own swim lane. We put a heading on the swim lane to show who the person or entity is doing those activities. Each activity is represented by an oval or a square with rounded corners. An activity is some action or one of the steps in the workflow. Activities are connected together with arrows. The arrow is a transition from one activity to the next. The direction of the flow is indicated by the arrow. To start and stop an entire sequence of steps, we often use a pseudo-activity. These are simply solid black circles. They don't have any other meaning than start and stop. You see that the ending pseudo-activity has 2 concentric circles. Obviously, with any flow of activities, we sometimes have different paths that we can take. A path is nothing more than a set of connecting activities. If we have an either-or condition, in other words, taking one path or the other path, but not both, that is a decision point. There are 2 ways to demonstrate decision points, either with 2 or more outbound arrows from an activity, or by adding a decision diamond with outbound decision arrows on the corners. Remember, this is an OR condition, taking one path or the other, but not both. On the other hand, sometimes we have situations there are multiple paths and both must be taken. We often call this concurrent paths because they both must be followed concurrently. This is an AND condition. To demonstrate concurrent paths, we insert a synchronization bar. We insert one at the beginning of the concurrent paths to indicate a split, and one at the end to show when they come back together or where they join up again. Although not shown on this diagram, we also use synchronization bars to denote a loop. One bar to begin the loop and another to show the end of the loop. Let's look at the workflow for an RMO, order fulfillment process. This activity diagram illustrates the components that we just discussed. In this case, we start in the warehouse swim lane. After the beginning pseudo activity, the first activity is to select an order to process, which is done by someone in the warehouse. After an order has been selected, the transition flows to the order subsystem to locate the order in the database. It then passes that information to the inventory subsystem, which then loops through an order for each item on the order. Notice that we use a synchronization bar to indicate this looping process. There are beginning and ending synchronization bars. Within the loop, the inventory subsystem finds a warehouse that has the item in stock. We have added a decision point to indicate if that item was found somewhere in some warehouse. This decision diamond may or may not describe an activity or some action. In this case, it just asks a question. If the stock was found, then somebody in the warehouse pulls that item from stock so that it can be shipped. If no item can be found, or after the item is pulled from stock, the flow then goes to decrement the item stock count. Even if none is found, one has been ordered, so the inventory count may go negative to indicate outstanding orders. Then the loop ends. The order subsystem then sends the shipping details, such as customer address, to the warehouse so that it can prepare the shipment. The shipping company receives the information about the shipment and creates a tracking record in the database. That information is passed back to the warehouse. At this point, the path splits into two concurrent paths. The warehouse sends the shipment to the shipping company, and the shipping company receives the package and takes control. Meanwhile, on the other path, the order subsystem updates the order information with information about the shipment. Both of these paths converge on the ending pseudo activity. We could also have shown a converging on an ending synchronization bar and then ending, but since nothing else is happening, this is sufficient. Let's look at an activity diagram with several swim lanes. This activity diagram documents a workflow to process a new order in an engineering company. The workflow might be titled Prepare Order for Production. In this activity diagram, there are 5 swim lanes representing 5 different entities that participate in the workflow. The beginning pseudo activity begins in the salesperson swims lane. The first activity is done by the salesperson and is to accept the order. The output transition flows out of the salesperson swim lane over to the engineering swim lane. In this case, we have shown that the transition is also accompanied with a document, the order. This is an optional notation that is used from time to time to show the movement of some type of document or article. The transition ends on the make specification activity, which is sponsored by engineering. Out of make specification is split with the synchronization bar. Remember, the synchronization bar is used to split a path into multiple concurrent paths. So in this case, the activity buy materials is performed by purchasing is concurrent with the activity program computer performed by production. These two paths then join back together before entering the schedule production activity performed by scheduling. Note with synchronization bars that separate paths must start at the same time, both begin concurrently, and they must end together. In other words, both paths must come together at the synchronization bar before flowing to the next step. If one finishes before the other, it waits. Note the ending pseudo activity. One interesting point about this activity diagram is that there is probably a use case for each activity. In other words, there could be a more detailed workflow within each activity shown on this diagram. In essence, this is a high-level workflow diagram which goes across multiple groups. Finally, let's just review the steps necessary to create an activity diagram. It's quite straightforward with only a few steps. First, identify all the participants in the workflow and make a swim lane for each one. Placement of swim lanes is not important except to make the workflow easy to draw and to read. Decide where the starting pseudo activity should go, in other words, in which swim lane. It usually is the same one as the first activity oval. Draw the ovals and the transitions based on the workflow steps. Add decision points for OR conditions. Add synchronization bars for AND conditions and for loops. Very simple process with a few steps to create an activity diagram.